By now, we have an idea of what the consumer wants. The consumer typically wants more of everything. Human desires are unlimited. However, the consumer is also constrained by what they can get, by what is feasible. We label the potentially unlimited satisfaction the consumer gets from consuming things with the concept of utility. We also label what the consumer can get with the concept of a feasibility constraint. So the choice the consumer is facing is quite simple, actually. The choice is, how do I get the maximum utility I can get when I know my own constraints? In other words, the consumer is trying to answer the following fundamental question: how do I choose what's best for me? We have all the ingredients to address this question. Answering this question is what this video is about. The easiest way to see what's best for the consumer is by using a graph. On this graph, we can place all the indifference curves which the consumer has. Please recall that the higher indifference curves mean higher utility. So the consumer is trying to get to the highest possible indifference curve. At the same time, however, getting there is constrained by his feasibility constraint. The indifference curve tell you what's desirable, and the feasibility constraint tells you what is feasible. So this graph combines the two. This combination then will tell us what's best for the consumer given his constraint. So let's see. Let's start with some arbitrary point on the feasibility constraint. Let's call these points A and B. Are these points feasible? Yeah, by all means. However, notice where they sit. They sit on the lowest possible indifference curve. So can the consumer do a bit better than that? I believe they can. So let's keep looking. The points on the lowest possible indifference curve are not good enough for the consumer because we know they can do better than that. For example, they can hop on a higher indifference curve, which makes them strictly better off than before. For example, they can get point C. Point C is definitely better than point A and point B. But we know that if the consumer chooses any point within the feasibility constraint, he's wasting resources, right? So how about point D? Point D is equally good as point C, and the consumer is not wasting any resources by choosing point D. But is it the best the consumer can do? Not yet. There is a point on a yet another higher indifference curve, which is still feasible. The consumer is able to get this point. It will be within his feasibility constraint, but it will bring him an even higher utility than point D. What's that point? Well, this point is E. Point E, notice, is the only point which satisfies two important conditions at the same time. First, it maximizes utility, and second, it is feasible. So point E sits on the highest possible indifference curve within the consumer's feasibility constraint. When a consumer has reached a point like that, we know that they're in equilibrium. The equilibrium for RLXA in this case is 19 hours of free time and 57 grade points. Note that point E is a point belonging to both the indifference curve and the feasibility frontier. But as this is the only point they have in common, the slope at that point is equal for both the indifference curve and the feasibility frontier. You will recall that the slope of the indifference curve is called, right, the marginal rate of substitution. At the same time, the slope of the feasibility frontier is called, right, the marginal rate of transformation. As the two slopes are equal at this point, we have an equilibrium result that in point E, it is true that the marginal rate of substitution is equal to the marginal rate of transformation. What we just did is apply a method to solve an economic problem. We call this method constraint optimization. In a constraint optimization problem, an economic agent chooses what's best for them given their own constraints, just like Alexei did a minute ago. As the economy is full of agents who are trying to maximize certain things they care about within their own constraints, this method will be perhaps the most widely used method you will see in your microeconomics classes next year. Note also that this method applies not only to consumers who are willing to maximize utility and to firms that are trying to maximize profits. There are a number of other examples we can find in which constraint optimization determines what's best for certain economic agents. So we'll discuss some of them during the live lecture. In the next video, we'll see how technological improvement changes the feasible set and how the change in the feasible set affects the optimal choices consumers make. Keep watching to learn more.